recent events, right? Of it in the context of emergency communications, which it's very useful for. Katrina, 9/11, the Northeast blackout, and all those events are all good examples of relying on amateur radio to sustain communications in conditions where other infrastructures weren't available. So that's probably the context in which most people hear about it, because that gets the news coverage. But amateur radio is a FCC service that is available to anyone who can pass the exam, which is very simple at this point, and just play around. It's really more of a hobby than anything else. And
there's levels to the licensing. The most basic license right now is the technician class, which is a no-code license. You're not required to learn any Morse code, which used to be a stumbling block for some people. Recently, the amateur radio was completely restructured in that there's now only, I guess, essentially 3 licenses. There's technician class, general class, and extra class. What you get with the technician class is probably 99% of what anything a geeky person would want to play with on the radio. The only thing you really don't get is access to what's called the HF bands, which are traditionally known as the shortwave bands, frequencies below 29 megahertz. Down there's a lot of other interesting stuff, and to get access to that right now, you still have to pass a code test within the year. That'll probably go away. But the general class gives you initial access to the HF frequencies. The extra class gives you an extra chunk of those HF frequencies, and that's probably all you need to know to get started. But the tech license is the entry key, and it's relatively easy to get. As we were saying before we started, right now the FCC has reduced the question pool to 300 questions. You only have to take a 35-question multiple choice test, and you only have to pass 21 of those questions, and you're there. And the opportunity to actually take that test is going to be presented tomorrow, and some of the other members in the group will be able to talk more about the details of that, but we will have testing here at the conference.
And I wanted to explain to people who here are not very technical that the radio spectrum is really... The radio spectrum is pretty broad. Most people are just familiar with frequencies that maybe they watch television over the air or listen to FM radio or AM radio. All of these are really chunks of the electromagnetic spectrum. And this is a chart showing most of the useful electromagnetic spectrum as chopped up and allocated by the United States government. And you'll see all these colored blocks there, and it's really a crazy patchwork quilt of frequencies.
All the blue blocks up there are all broadcast blocks. So, for example, the big one on the second row is the AM broadcast block, right? That's the location that you would find if you're tuning around your AM broadcast radio. A couple of the other ones on the fourth line down are television FM stations and also FM radio stations, just to give you an idea of where things are located.
In fact, let's point to just a couple of common areas on this. It's kind of like a timeline. Lynn, can you point to like the AM radio band?
Yeah. Now, keep in mind one thing is that it's not 100% to scale. So don't. I mean, the broadcast people have a lot of spectrum, but the one thing when you look at this is that it makes it look like they have particularly in the AM broadcast band is not that incredibly wide. But here you go. I mean, that's standard broadcasting AM.
The scales become more compressed as you go down each row, just because of how much bandwidth you have on each row there. So this goes from DC all the way up to like 300 gigahertz, right? So
right.
you have a difference in scale from the first row to the last row.
So you can see the AM radio band, which is more accurately referred to as the medium wave band, is near the bottom of this chart. It's pretty low in frequency. It's around 1 megahertz. And Lynn, can you skip up to the FM broadcast band? I'm just giving these bands as examples because they're the ones lay people are most familiar with. Because people listen to the radio. Go ahead.
One of the things that makes ham radio fun is that we don't need as much bandwidth as the broadcasters to do our thing. Where a broadcast signal to just say maybe has to be that wide, to use a very coarse way of showing it, we only need that much. We can get by with as little as 250 hertz and still get a signal out to other people. We have to use specialized techniques. We have to learn specialized skills, but that's what makes it good. We don't need either the bandwidth or the power. It's possible with amateur radio to talk to anywhere on the planet with less than 1 watt. Compare that to the megawatts that an FM broadcaster might use.
And also to clarify the difference between the terms broadcasting and transmitting. Broadcasting, by definition, means you're transmitting a signal and you don't have a particular individual in mind for receiving it. Broadcasters, like commercial radio station, they just broadcast, and whoever listens to is great, many as people possible, as opposed to non-broadcast, which would be everything we're really talking about here today, which is you have a specific individual or a group of individuals you're communicating 2 ways with, back and forth. So none of the things that we're going to discuss today are really about broadcasting. They're about transmitting. And you cannot broadcast as an amateur radio operator or any of the other services we're talking about. You can transmit with a specific audience, specific recipient in mind.
There's a couple of very narrow exceptions within that, but that is the absolute general rule. And still, your target audience or your target is amateurs when you're talking about amateur radio. But I just wanted to point out a couple of things. You see this big block of a lot of blue stuff, but you also see a pretty good chunk of the green stuff, which is amateur in here. And sometimes they butt right up against broadcasting, but a lot of people are kind of blown away by the fact that FM radio kind of butts up right against TV, because they're channelized in within FM radio or AM radio. You get a frequency. Within TV, you get a channel, and a lot of people don't put it together. So when you look on here, you kind of get an idea of where things lie and what's next to each other. But you get in down here, you get into some interesting things that are overlapping where there's a lot of sharing, and we'll talk about that in a little bit.
Can you point out, Lynn, some other frequencies people here are most familiar with, like a cellular telephone and PCS frequencies? They're typically around the 800, 900 megahertz band and the 1900 megahertz band. And Lynn's going to point out where those frequencies lie on the spectrum.
Well,
it's kind of hard because we have some fine print here. But it's just a huge resource available to the public, the electromagnetic spectrum.
So to give you an idea, next to almost every chunk of broadcast bandwidth available, there's almost always an adjacent chunk somewhere in the vicinity for amateur radios to use. So every type of propagation that you would get with the shortwave bands, with the shortwave broadcast bands, the stations you can hear from Europe, and the medium wave band and the FM band, you can also get with amateur radio.
Assuming you choose to join us, which we hope you do, one of the things you'll find discussed amongst amateurs is frequency access and frequency control. There's a political end to that. There are some of our frequencies that are coveted. If you follow anything in broadcast news or anything in commercial radio news, the FCC essentially sells frequencies to commercial entities, and they make money on that. And whenever there's money on the table, things get interesting. So every now and again, some amateur radio frequencies look like they're on the block. The biggest protection we have against the government taking those away is our use. And our use of those frequencies for good purposes, emergency communications. So keep in mind that when you enter into this, don't just get your license, get on the air. It's very helpful to the overall cause of keeping the frequencies that we have.
And I'm pointing up here to 50 to 54 megahertz, which is commonly referred to as 6 meters, because that's approximately the wavelength. And as you see, it comes right up against channel 2 through 4. Well,
TV channels 2 through 4.
TV channels 2 through 4. And you'll notice that there's no channel 1. Well, guess what? It was right here. And channel 0 was right here. And in other parts of the world, that's where they are.
Any native New Yorkers here that used to have rabbit ears? Yeah, you'd know if you had a 6-meter operator living near you. Because of channel 2, right?
Now, I'll tell you one thing about this. There was an amateur who put a petition before the FCC to reallocate 50 to 54 to FM broadcast. And fortunately, it failed. Now, it would be nice to have more FM broadcast frequencies, and that would help Prometheus Radio and a lot of other people, but at the same time, it takes away from another service.
And all these frequencies, too, a lot of these are grandfathered. Maybe, Joe, you can discuss, or Skip might even have better history on this. When radio was a new technology in the early part of the last century, the government decided they had to manage it at some point. And originally, it wasn't managed at all, right, Skip?
No, it was wide open. Everything was a pirate radio station. But what happened was the government, with the understanding of the technology at the time, in the early 1900s, they looked at the spectrum from what their physicists were telling them and said, everything up here above 200 megahertz, that's never going to be useful for anything. Let's give it to the hams. And what happened was, we not only found out that it worked, we found out that it worked better than anything else. And that's basically what we now call the not 200 megahertz, 200 meters, I'm sorry. But the situation is that we discovered the technology as hams to make that stuff useful. So then they chased us further up the band and said, there's nothing up there above, nobody's going to have a practical use for anything above 150 megahertz. We came up with repeaters, we came up with satellite communication that was cheap enough to be done by somebody other than NASA. Wherever they stick us on the band, we creatively find ways to make it work. Because unlike when you go out to, you can use FRS, GMRS, any of those public access radio frequencies very easily. You can go right out here on the street corner and buy the radios. But you can't build your radios, and you also can't experiment with those radios. Hams can build. We are the last. We can build, we can experiment, we can try new things, we can come up with new ways of doing things without applying for any kind of special dispensation from the FCC. We are supposed to experiment. And last time I checked at a hacker gathering, I think that's what we like to do.
And there's an interesting compliment here with the amateurs and amateur radio operators and hams and the hacking community. Ham radio operators early on are really the first electronics hackers, communications hackers. They figured out ways to use communications technologies, new technologies, to communicate with each other. It's analogous to phone phreaking, exploring the public switch telephone network. Well, hams, early part of like back in the 20s, they figured out ways to communicate wirelessly. And we think wireless communications, that's a new thing. It's been around for like 80, 90 years. And the original hams, who didn't even be licensed because it was such a wild west of non-regulation, which was kind of good.
The two-tone phone frequencies that you hear when you dial or when you play around with a DTMF or something like that, there was a time that Ma Bell wouldn't let anybody touch those. Hams started using them for control applications on repeaters. And it was partially due to the ham radio community needing access to that technology that started some of what became eventually the telco breakup. So we're in the ham radios are in the midst of all this stuff.
So first, let's explain maybe what sort of different things we can expect from different parts of the spectrum. So how many of you guys are familiar with shortwave radio and have listened to international broadcasts? So a good chunk of you are familiar with that and are familiar with the kind of propagation that you can expect, but maybe some of you aren't. And so at the relatively lower end of the RF spectrum are the HF bands, which is counterintuitive because that stands for the high frequency bands. A long time ago, they were considered the high frequency bands because, like I said, like Skip said, there wasn't really much going on in VHF and UHF, which is very common today with the handheld radios. So the kind of propagation that you can expect are when you're transmitting or receiving on these frequencies is stuff from all over the world, depending on the time of day, depending on the season, depending on the sun, where you are in the sunspot cycle. Different frequency ranges will propagate differently And by propagation, I mean bouncing your radio signals off of the atmosphere. So you literally transmit your your RF goes up into the atmosphere, bounces off the ionosphere, comes back down again, maybe bounces off something else like an ocean or a piece of land that happens to be reflective to RF, goes up again, bounces back down again, and this can happen for, until you get to the other side of the world. And this is what enables us to communicate across the world. And the physics of this gets, pretty complicated, but it works really well. And this is what enables worldwide communications without any infrastructure at all. So that happens at the lower end of the RF spectrum. Once you get up into the VHF and UHF sections, there are types of propagation that do work like that, like ducting and other sort of interesting features, but it's mostly line of sight, so you would be expecting local communications, the kind of stuff that your police department and fire department use, and it all works the same in the amateur radio service as it does in the business bands and everything else. So that's sort of where you stand as far as what kind of propagation characteristics you can expect. Generally speaking, the rule of thumb is the higher up you go, the more dependent upon line of sight you are, and the lower you go, depending on the range, propagation characteristics differ a lot.
Yep. The exception to that is two things we have access to that are pretty unique. As hams, we have access to satellites and we have access to the moon.
Which is a satellite in itself, just a natural satellite.
Right, natural satellite, right. And what happens is that, as Joe was saying about bouncing the signal off the atmosphere, being controlled by the quality of the atmosphere on any given day, a satellite is an artificial version of that, whether it's the moon or an artificial satellite. We bounce the signal off that to give it further distance. There's 12 or 13 ham satellites up right now. I'm trying to remember.
There's a bunch. You can look them up online.
Used to be one, now there's a bunch. The ISS space station has amateur radio capability, performing very much like that. But then moon bouncing is probably the most incredible and most advanced thing you can do in amateur radio. It's not for everybody, largely because of the cost. But the ability to basically use the moon as a passive reflector to carry your signal around the world, that's pretty slick.
So, and I wanted to talk a little bit about a couple of kind of a base. We talked a little bit in some detail about amateur, but this is kind of what you're seeing up there is kind of a rough snapshot of some of the things we've talked about. You've got a lot of different types of communication modes, lots of ability to experiment. High power communications are permitted based on your license class up to 1,500 watts, which is,
a huge amount of power.
Way more than you need.
Right.
For most applications, it's way more than you need. But the ability to use higher power, and the reason that they limit it with license classes, because they teach you a lot. There's a lot of stuff in the higher license classes about RF safety and how not to fry yourself. One of the restrictions that we also didn't talk about was no business communications. Okay, it's purely amateur, as defined cleanly, for the love of the communication, and that's probably one of the things that you found that Bernie and I have discussed a couple times at fault level with ham radio, is that hams like to talk about ham radio a lot, and not a whole lot of other things. So it can be used for other applications and relief, but if you listen to a ham radio band at any given time, you're going to hear a lot of people talking about what they're using, how it works.
As a card-carrying member of the Sherlock Holmes Amateur Radio Society, I beg to differ with you on.
Okay.
Well, there are people that talk about other things on the radio.
Yeah, there are, but there are a lot of people that will talk about, if you tune across a band, a lot of times the majority of what you're going to hear is people giving signal reports and talking about
improving the quality of their signal and their equipment. All about improving. There's a phrase used actually in the FCC regulations, improving the radio art. And it's a very powerful statement. The idea that we're not just supposed to get out there and talk to one another. We're supposed to do things to make our own stuff better and work together to make everybody's stuff better. That's that's, there's nothing more exciting than learning something new and trying it out. And ham radio lets you do that.
And so what Lynn was mentioning, that a lot of hams talk about, only ham radio, but like Skip mentioned, that's not necessarily true. And it's like that with any sort of hobby. If you get a bunch of people who are into like golf together, right, the first thing that they're probably going to start talking about is golf, and it's sort of like a common ground. And conversations on the air segue into a whole realm of different things. So it's not limited to ham radio, but it's generally what you hear when you first start a QSL.
And if you want to use two-way radio communications for business purposes, it would be restricted away from amateur radio. There's other technologies we've mentioned. Family radio service. A lot of you've seen these walkie-talkies you can buy for very inexpensively.
Out of order.
Sorry. GMRS, General Mobile Radio Service, and I think it's the acronym, isn't it?
Yeah, General Mobile Radio Service. And some of the things are on here. You can conduct quote-unquote personal business. As compared to ham radio, it's a UHF allocation in and around the generally assigned business bands.
And there's 16 channels.
And some of those are shared with the family radio service. And you're limited to a maximum of 50 watts, and some on other channels. You can use a repeater, which is a device that sits on a tall building or mountaintop or whatever, that receives on one frequency and retransmits on another simultaneously to extend your range as if you were on top of that building or mountaintop. And there's no antenna gain restriction on GMRS, so 50 watts is way more than enough.
And a lot of the small radios you can buy at local stores as consumers will do both GMRS and family radio service frequencies. And there's 14 family radio service frequency allocations, and there's 16 GMRS frequency allocations.
GMRS requires a license, though, right?
It does.
Yeah, you have to. It's $70 to apply, and I think it's $35 a year or $70 a year, something like that. But that's per family. Did it go up to 80?
I think it went up to 80, yeah. I have to look at my...
Very few people actually buy those licenses.
Yeah. The majority, let me just tell you, the majority of Walmarts use GMRS, and they've never paid for a license in their life.
FRS, Family Radio Services, essentially is the modern version of CB. Citizens Band is still out there, but FRS is basically you can walk into a Wally World and for $30 have communication.
Another one that's recent, has been recently allocated in 2000. GMRS has been around for a long time. Okay, MERS, multi-user radio service, is five. There's five VHF allocated channels. There is no license required. The FCC didn't want to process licenses. 2 watts maximum power. There are some restrictions on how high the antenna can be, but no restrictions on how much gain the antenna can have. With one talkie to another talkie, you're looking at about 5 miles. There's no rules on content. There's no rules on encryption. But you have to use an FCC-approved radio, and experimentation other than your antenna is not really allowed. You can use low-speed data, and when I say low-speed, I mean about 1200, 2400, maybe 4800 baud, but you have to stay within the emissions, the bandwidth allocation for MERS.
Lynn's next to last bullet point is always, in my mind, the most important one related to why amateur radio as opposed to any of the other services. You must use an FCC-approved radio, no experimentation. Ham radio operators can build their own radios and experiment with them. And Joe on down the end of the table has 2 radios he built. Neither one probably cost him more than $20 to build, and either one has the capability under the right conditions to communicate anywhere around the world.
Do you want to do the last couple slides?
Yeah, we'll finish discussing all of the different types of services available, and then we'll go into specific applications of amateur radio and how we can use different modes and stuff to communicate. But first, we'll finish with the different services. So Part 15 is...
Part 15 is the one place where you can experiment without a license. Okay? You can build your own equipment within certain criteria and power output levels. The output levels are very low, okay? Very low. There is some allocations all over the radio spectrum for Part 15 use.
Mostly the ISM bands, which are on that chart as well, and those are areas where you can use a certain amount of power and with other restrictions.
Right. And there's people that communicate over hundreds of miles with Part 15. I wouldn't say that it's something that would be a reliable form of communication, but it's certainly the place to experiment. You can broadcast, although in extremely low power levels, in the FM broadcast band and in the AM broadcast band. I don't believe that you can use Part 15 within the TV band. Specifically, they got rid of a lot of that stuff in the 70s and 80s.
The application you may see this used on a daily basis would be if you drive around and you see real estate for sale, and they might have a sign, tune your radio to 1600 or 1610 to hear about the house. Those are usually Part 15 transmitters.
And even more commonly, if you have an iPod or CD player or something, and you want to hear the signal on your car stereo system without connecting it directly, like just tune it to a certain frequency channel on your car radio or whatever, that's a Part 15 transmitter. So when you have one of these, what do they call them? Like
iTrip
is one, and if you've used one of these, you know how incredibly poorly they work.
And by the way, if you search on the internet, they're actually hackable.
Yeah, you can play around with those a lot. It's the output power level. A lot of people say, oh, as long as it's a quarter of a watt or less, it's okay. But that's not really the case. If you read the rules specifically, it's something very complicated and nebulous to most people. Part 15's real intention is for manufacturers to be able to make consumer electronic devices that
don't have to be licensed.
That don't have to be licensed.
So any sort of small scale wireless device like a garage door opener or your portable phone in your house or a remote control for some device is almost always Part 15, and you can find this specification on the back. There'll be stickers that mark that.
So does anybody else? There's one other probably most used Part 15 device that's at this conference. Does anybody have any idea what that is? Wi-Fi. There's also an interesting caveat with Wi-Fi, interesting situation with Wi-Fi. That's a ham radio band too. We share that, and I think this is a good place to talk about primary and tertiary and secondary and all that other stuff. Government is primary on 2.4. Radio location is secondary. Ham radio is tertiary. Part 15 is
way below that.
Dirt. Okay.
And the Wi-Fi band was most commonly used by all of us with our microwave ovens. Same frequency band.
That was the first application. Well, probably the first common application for that.
Back in the 70s, early 70s, when microwave ovens first coming out, the FCC figured, we got to put these on because it's radio energy. Let's define a frequency band we're gonna put these things on so they don't interfere with other services. And
well, they didn't really have much of a choice, right? It's the resonant frequency.
Well, when the 900 megahertz portable phones started to come around, I could always tell, when my wife was making a cup of tea downstairs, because I'd hear the signal on my
More recently, cordless phones came out on 2.4 gigahertz and then Wi-Fi. So that's why you have some interference sometimes with your Wi-Fi services. There could be somebody with a cordless phone or a microwave oven interfering with it unintentionally.
Or it could be your neighbor that's a ham that's running a 10-watt amplifier. So we can legally do that. Actually, we can legally run 100 watts spread spectrum with power control or 10 watts without power control. And if you've played with Wi-Fi, that's a lot more power than your average person needs.
So think about this. A hacker can own Wi-Fi. Might want to become a ham.
You can do all sorts of experimentation if you modify your equipment to be able to transmit an identifier such as your call sign, which is one of the requirements of using the service, and play with this stuff, and you have privileges over what Part 15 allows you to do. So if you're interfering technically, they have to accept that.
Yeah,
And
not
not
only
that you
you
want to
have to-
intentionally interfere with anything, but if it's part of the service, it is something that you have privileges over, a Part 15 device.
And if you flip over your Part 15 device, your pick a Part 15 device, your television, turn it around, read the back, and it says this device must accept harmful interference, even interference that may cause unsatisfactory operation. So if a ham, and this is a very common scenario, if a ham gets into your telephone line, and it's a Part 15 telephone, it's up to between the two of you to, ham will try to work it out with you, a good one.
In almost every case, they're very cooperative and will help you eliminate the interference or adjust their station to eliminate the interference, because nobody wants to cause a problem, but you technically don't have any say over the matter.
Right.
So we can probably get into specific applications of amateur radio so that we don't run out of time with that stuff. And
Just real quick, Lynn's going to touch on the CB radio frequencies.
So there's 40 channels. Experimentation other than the antennas is not really allowed. You can have long-range communications, but it's technically not legal. There's actually a I think it's 50 miles or something, 150-mile cap that you're not supposed to talk further than that. I don't know exactly how the FCC runs out and blocks the radio waves, but that's the cap that's out there. You have 40 channels and 2 modes, AM and single sideband, which is single sideband is kind of a modified AM that goes a little further. And then
you can use the CB for like Family Radio Service, FRS, and GMRS. You can use CB for any business purpose. There's no restriction in that. You can't broadcast music, but you can, if you run a taxi cab company, you can use CB radios for that.
And this is where you get into one of the overlapping gray areas of ham radio and other services. Is the CB band is immediately below or immediately above, depending on how you look at it, below the 10-meter amateur radio band. CB band in other countries is actually a ham band. In Japan, for example, it's the 11-meter ham band. What happens, and is all too common, is people who have a need to use CB will buy amateur radio gear, which can use substantially more power, as we've discussed, and modify it for CB use. It's very easy. It's probably no more than tweaking a couple of capacitors or coils. With this in mind, you'll run across these stories where you hear about truckers or the most common story you hear is a trucker running 1,000 watts out of the cab of his truck. He's probably using a modified ham radio. But that's one of those interesting, strange areas that's fun to at least pay attention to. But 10 meters is us, and no one else is supposed to be there unless they're licensed.
all right, so should we segue now to the ham stuff?
Yeah.
All right, so we can start talking about some specific applications of amateur radio, and I don't know, we could start with the QRP stuff. I know Skip's into it, and I'm real into it as well. One of my favorite modes of operating within the amateur radio service is something called QRP, which essentially means very low power operation.
Yeah, QRP, the term QRP comes from an old Morse code signal, which means reduced power. You would send QRP to tell somebody to reduce power. The amateurs are actually, if you read the regulation, we're more or less obliged to use even though we're qualified to use 1,500 watts, we're obliged to use the lowest level of power necessary to complete the communication. People like Joe and I take it to the extreme, and we drop QRP within the amateur radio community is essentially considered 5 watts or less. Then below that is QRP sub P, which is 1 watt or less. And there's people that go lower, QRPP, that's the room in the back, where people use less than half a watt. People have successfully, the standard award, if you want to call that, demonstration of your amateur radio skill is working 100 countries. People have worked over 100 countries. People have worked over 200 countries with half a watt. It requires skill, but the equipment is easily affordable, as you're about to find out.
Okay, so one of the cool things about QRP equipment is that it's not dangerous to work with. You're dealing with very low power levels, so it's totally okay to experiment with. and generally very easy to build. You don't have to worry about much in terms of interfering with other things. One of the main things that's required when you build your own equipment is obviously making sure that you're not interfering with any other services. And so you have to really be knowledgeable technically about what you have to do to filter harmonics and other things. And with QRP equipment, it's very easy to satisfy the requirements, and there's not a lot of hefty equipment involved in that. An example here is a little QRP transmitter. This one's actually very common. You can do, I think it was first released in 76, and it was released in a very common amateur radio magazine as a QRP project. And so this guy published a schematic of the Tunitin 2, which is the name of this transmitter. And as you can see, it's built in an old tuna can. The circuit board lays on top of the tuna can, and all the components are kind of sticking out the top. So it's one of those show-off rigs where you can see all the circuitry. But this transmitter operates on the 40-meter band, which is a very, very common band that's also used by broadcast stations. So when you're
international
shortwave broadcast stations, so your likelihood of picking up European stations and stations around the world at nighttime is very, very high. This transmitter puts about a third of a watt out, and you can use it literally to communicate across the world. You can power it with something as simple as a 9-volt battery or a car battery, and it'll last for hours and hours and hours. I also have another QRP radio here. This design is based on the Pixie 2, and this one doesn't have a printed as nice of a printed circuit board. It's just basically perf board. It's hard. Sorry, this isn't working very well. We don't have very good lighting here, unfortunately. But if you can see, if I can get the light to reflect off of it, this is something that I just built on a piece of perf board. All the components are on the top, and this is called, I guess, sloppy style construction. Everything is just soldered on the bottom, and a standard hookup wire. And this is a transceiver, whereas the Tunitin 2 is just a transmitter. I'm sorry. And right now they're both operating on the same frequency. So I can give a short demonstration of very close range communications. When I transmit with the Tunitin 2, it's going to sound worse than it would normally sound because I'm not loading it up correctly. The antenna is not what it's tuned to be, so it sounds a little bit off. But the this other QRP receiver here is powered off of a 9-volt battery. The Tunitin 2 is powered off of this power supply. It can very easily be powered from the battery or from a car battery as well. Yeah. So
either of these circuits can be built for under $20.
Well under $20.
If you have a junk box, you probably have everything you need.
Right. So this is an example of a Morse code transmitter. This is all Morse code. This is the key I'm using. If you can see it, this is a little portable CW key. I'm sure you guys have sort of seen these things in, I don't know, people have seen them.
Yeah.
People recognize them.
While CW is no longer required for the basic license, it's a very efficient mode of communication, especially at low power. So people who get into QRP inevitably find their way into Morse code. And it's really not as hard as people make it out to be.
So basically what it does when I key down is basically turns on the transmitter. And the transmitter is a very simple oscillator, which is what creates the RF frequency, and an amplifier. And it puts out, like I said, about a third of a watt. So I just ID'd our station, which is N6H in Morse code, and that's all it takes. I mean, these two devices right here can literally enable you to communicate around the world, and they were both built on a weekend, and you're using an incredibly small amount of power. A typical antenna for this sort of a setup would be a dipole, and for 40 meters, the dipole length would be 20 meters long.
And just for people that know, a dipole is just really just a piece of wire that's. Why don't you explain the length of?
You would have about 10 meters on each side, and it would come down in the center with a piece of feed line, and that's really all that's required. You would connect it to this circuit board right here, and stick it as high as you can.
It turns out to around 62 feet-ish,
right,
give or take.
And you mount it as high as you can, preferably in free space, and that's really all that's required for a simple, very basic antenna setup and a transceiver setup is what I have here with 2 pieces of 10-meter wire.
And Skip, can you give some examples of? I know you've been operating QRP for a really long time. Maybe not really long time, but with equipment like this, you've communicated with other people. How far away?
One of within the QRP community, the gold standard award is something called 1,000 miles per watt. I communicated with the Marshall Islands with a half a watt.
And where's the Marshall Islands?
Over there. Other side of the world. I've worked over 150 countries. I've worked all the states. I've worked all the states on 3 of the bands. I have a couple more to go. It's a challenge. Right now we're at it's called there's something as you get into this, you learn about the propagation cycle and the sunspot cycle. And right now we're at the very bottom of that cycle. It's very hard to communicate great distances with QRP, although it's still possible. 6 years from now, I'll be able to talk to everybody again. But it's just one aspect of the hobby. What's nice about QRP is right within the hobby now, although there's experimentation everywhere. A good chunk of the experimenters are playing with QRP. The idea that you can build, you can basically take an old radio out of a trash can and turn it around and make a transmitter out of it. If you know which parts to pull off that circuit board, that's pretty exciting to me. I have to confess that I enjoy building probably more than I enjoy operating. So I'm as likely, like Joe, I'll build that, put it on the air, and throw it on the shelf and go build another one. You know?
And the concept that a lot of people don't get is because we're conditioned in a consumer culture that if you want to communicate, you have to pay some company or entity to use their infrastructure. This isn't using any government or corporate infrastructure. You're communicating literally around the world for free, without having to pay any monthly fees or buy an expensive cell phone. That's one of the beauties about this kind of communications is you're not dependent on another entity for their network. You can communicate around the world for free.
Now, as a counterexample to all this QRP stuff, which is home-built radio equipment, I have an actual commercial transceiver out there, up on stage, facing you guys. Hopefully, you can see it, and I could just show you real quick how this works.
No, but if he promises not to transmit, I'll still.
So commonly with QRP equipment, a lot of it is crystal controlled, which basically only allows you to use one frequency at a time. I'll show you what the crystal looks like.
Can we zoom in the camera in on the podium for a second?
Will that work?
That works.
Okay, so this is what a crystal looks like, and this is basically literally there's a crystal in there, and it's cut to be resonant on the frequency that I want to use, which is 7.040 megahertz. And
just coincidentally, that crystal is the same package size as the crystals that I ended up going to federal prison for distributing here. Those crystals are 6.49 megahertz. So crystals can be used for a lot of things.
So basically, that circuitry uses that package, that crystal, as a reference point for keeping everything very stable at that frequency, and it works very well. Commercial radios, you won't find that anymore. 40, 50 years ago, that was more common that you would have a crystal option with the radios. But radios these days use what's called a VFO, which is a variable frequency oscillator. And you'll usually see, these big knobs on the radios. And this basically allows you to tune around. So right now I'm set on 7.040 megahertz. Did you unclip something?
I was going to put audio in it, and I got a clip lead.
Oh, but did you take it from the end?
Not to transmit. As long as you promise not to transmit, I'll hold it there.
If you took it off the wrong antenna.
If you start the process going down the slippery slope of becoming a ham radio operator and going to the VE training or taking the test, you'll start to realize that at this level, at the entry level for the hobby, the thing the FCC is the most concerned about you is putting out a clean signal on the proper band. It can be very bad business to be interfering with communications from an entity that's on a frequency that doesn't belong to you, and the FCC takes a very dim view of that. So when you take the basic test, you'll see the majority of the test anymore, where it used to really emphasize theory, it emphasizes rules and regulations, making sure you stay in the right frequency bands that belong to hams, and making sure the signal you put out is of high quality and doesn't interfere by having harmonics up into other people's areas of business.
And that's one of the main responsibilities that you have as an amateur radio operator, and one of the main reasons why they're so stringent with the exams and licensing procedures. So just as a demo of a commercial receiver, this is what it sounds like when you don't hear anything, and then I'll demonstrate with this QRP transmitter as well what it sounds like.
Is this up on the...
See, what Joe doesn't know is right now there's some guy in China who's hearing this saying, QRZ, QRZ, come on, come back to me, I need New York.
So that's what it sounds like when you use a commercial receiver. The transmitter doesn't sound its best, like I said, because it's not loaded properly, but it usually sounds much cleaner than that. And again, you can use it for worldwide communications. A lot of times, I hear people coming back to me with, 1.5 kilowatts or something, which is like the legal limit that they could possibly use. And I'm using, 1 watt or 2 watts or something. I'm like, okay, you could turn on the power.
And you're not limited to just, Morse code with the amateur radio service. There's all these other modes.
Yeah. And a lot of these are very. If your primary technology hobby is computing, we have plenty of modes that play with that. And some of them are coming online new, like D-Link. But we have Echolink, IRLP, Internet Relay.
These are both ways to tie local repeaters that are,
it's basically a voice over IP service.
Yeah, but done by amateur radio.
And interconnecting them over the internet. So in that sense, you are relying on a third party, but you're not relying for a subscription service. And then
we have our pure digital modes: Packet, PSK31, RIDI, traditional radio teletype. These are all Packet radio and PSK31 are very interesting, as again, you can use very low power. Basically, to put it very, very simply, you plug your computer into your radio and talk to people.
And it's just another form of text messaging.
Basically.
Not unlike your cell phone. Text messaging has been around for decades and decades.
But you don't pay for it.
But this is totally free, and you can send text messages back and forth around the world totally free. You can even send small files back and forth.
Amateur radio, go ahead.
While we're talking about Packet, I just wanted to real quickly show you this. This is a system that came out, and I've been involved with this since almost the beginning of it. APRS, Automatic Packet Reporting System, which uses an unconnected protocol to send position information, asset information, weather information, and it blows my mind every time I do this, but this is actually coming over the internet because of logistic stuff is easier to do it this way. But just to give you an idea of how many people are on APRS and assets are out there on the radio that get interconnected back through the internet, this is the New York tri-state area, and there's more people than that. These are just the ones who want to go out over the internet.
And this is all very easily able to be done without the use of the internet. You can have a radio hooked up to the sound card and have it demodulate those packets just as easily.
I don't know if you get the idea about how many assets are on there, but
these are just individuals. These are
just people with weather stations, and the green ones are digi. The blue ones are that cover the map over here. I can pick
It can be as simple as sending your call sign out as a beacon. It can be as complicated as sending telemetry from a weather station, information from any other resource that you can take, create into a packet and send out.
And they're voluntarily transmitting their coordinates, their latitude and longitude, so we can see in real time where all these other stations are. And if they're mobile, if they're in a car, if they're portable with a
and that's
handheld.
infinitely useful in emergency communications, which is its primary use in ham radio. Other things we get to do, we get two ways to play TV. Amateur radio, television, ATV, which is very similar to traditional broadcast TV, only you're talking ham to ham. But we have another mode called slow scan TV, which is done at HF frequencies, and
it's about a frame every minute or so.
Yeah, about a frame a minute, but it's still a practical form of communication for many purposes, using a very narrow bandwidth, less than a tenth of the bandwidth that a regular broadcast signal would have.
So there's an example of a picture that you could be sent from a radio from here. You could even be low power to another station anywhere in the world. It takes a little bit longer than conventional television, but you can send images anywhere around the world with other people for free.
And with fast scan, there's a very easy way to pick up fast scan if you do a little research and find out that you have fast scan TV in your area, which is standard television. Channel 57 or channel 58 on a cable TV, setting it to cable TV mode and hooking it to an outside antenna that's polarized properly, and you can pick up amateur television in your area if it exists. Every place doesn't have it, and it's not on 24 hours a day like a broadcast station, but you might see some ugly mugs out there talking to each other, or some nice attractive looking hams.
Unfortunately, we're starting to run out of time. Do you want to?
Yeah, so we're going to be here to talk at the ham station about this all you want, about extra stuff, but right now we want to hear some of your questions.
So anybody with questions that we can address,
Step up to the mic.
or whatever.
I was wondering if you could discuss GNU Radio, this open source radio movement, and what effect that might have on the whole ham movement.
GNU Radio is an awesome project. What GNU Radio is basically an open source software-defined radio project where you're literally using software to control the RF waveform, and that's up-converted to something that you can actually transmit with. And so all of the circuitry that that commercial transmitter is using and the commercial receivers are using is all done in software, and you have a very minimal amount of hardware that you're dependent upon.
There's actually a New Jersey QRP club, I think it's njqrp.org, sells a little, it fits in a USB slot, a little experimental SDR radio for about, I think it's Soft Rock 40, right? I think it's like $20-$30. You can begin to experiment with SDR for that little bit amount of money.
And basically, so it eliminates a lot of the dependency upon the hardware to generate the RF and to do the modulation and all that other stuff. So we can spend hours and hours and hours talking about software-defined radio, but essentially it moves all of the modulation and demodulation into software. So it's very, very flexible. You can come up with all sorts of modulation techniques that would never have been possible before.
Things we used to have to do with coils and capacitors, you now do with software.
You can write your own radio now.
You can literally write your own radio. So any other questions? Go ahead.
I just had a quick question. I'm new to ham radio. I was wondering why the restriction on encryption.
Good question.
Ham radio it's a public service. It's meant to be accessible by anyone who's using the service. With cryptography, they're not able to enforce any of the other rules, such as no business communications,
right,
and all the other restrictions of Part 97.
In order to get what we have to give a little back. And it's interesting when you brought that up, because the battle for that, we were only allowed until the late 70s. We were only allowed old-fashioned 5-bit Baudot RIDI.
Yeah, we couldn't use ASCII until...
It took us forever to get ASCII.
Yeah.
And the floodgates kind of opened after that. But the idea is that the purpose of our communication is to communicate to some degree in the clear with other people in other parts of the world. So our encryption is a little more open.
Next question?
Not much of a question, but more of a statement for everybody. Like, the ham radio movement, or whatever you want to call it, really needs us for people to experiment and go. I wouldn't say, no offense to anybody here, but the ham radio population is getting older, and they're stuck in their ways, and they really need people like us to start breathing new life into it. I've discussed on a couple of lists, like, geez, why do you guys do it like this way? You can use computers for this. And I've been regularly scoffed by older people. So just, take your license, get into it. It's a lot of fun.
It's a lot of fun. Unfortunately, we're out of time now, and we're going to be by the N6H station. We'd love to talk to you if you have any more questions that we can answer, or if you would like a demonstration.
The station... wait, one more question.
One more question, and then we're done.
One more question for the...
Okay, I have a question.
We're out of time. We can address it at the station. I'm sorry.
Yeah, I'm sorry. We'll have to take you on the side. We apologize. Thank you.
Poor guy. Jerk him around.
Thank you.
He takes a while to finalize. We can wind up taking the next person's panel time.
Individual in mind for receiving it. Broadcasters like radio commercial radio station. They just broadcast, and whoever listens to is great, many people possible, as opposed to non-broadcast, which would be everything we're really talking about here today, which is you have a specific individual or a group of individuals you're communicating two ways with, back and forth. So none of the things that we're going to discuss today are really about broadcasting. They're about transmitting. And you cannot broadcast as an amateur radio operator or any of the other services we're talking about. You can transmit with a specific audience, specific recipient in mind.
There's a couple of very narrow exceptions within that, but that is the absolute general rule. And still, your target audience or your target is amateurs when you're talking about amateur radio. But I just wanted to point out a couple of things. You see this big block of a lot of blue stuff, but you also see a pretty good chunk of the green stuff, which is amateur in here. And sometimes they butt right up against broadcasting, but a lot of people are kind of blown away by the fact that FM radio kind of butts up right against TV, because they're channelized in within FM radio or AM radio. You get a frequency. Within TV, you get a channel, and a lot of people don't.
Events, right? Of it in the context of emergency communications, which it's very useful for. Katrina, 9/11, the Northeast blackout, and all those events are all good examples of relying on amateur radio to sustain communications in conditions where other infrastructures weren't available. So that's probably the context in which most people hear about it, because that gets the news coverage. But amateur radio is a FCC service that is available to anyone who can pass the exam, which is very simple at this point, and just play around. It's really more of a hobby than anything else. And
there's levels to the licensing. The most basic license right now is the technician class, which is a no-code license. You're not required to learn any Morse code, which used to be a stumbling block for some people. Recently, the amateur radio was completely restructured in that there's now only, essentially three licenses. There's technician class, general class, and extra class. What you get with the technician class is probably 99% of what anything a geeky person would want to play with on the radio. The only thing you really don't get is access to what's called the HF bands, which are traditionally known as the shortwave bands, frequencies below 29.
A chart showing most of the useful electromagnetic spectrum as chopped up and allocated by the United States government. And you'll see all these colored blocks there, and it's really a crazy patchwork quilt of frequencies.
All the blue blocks up there are all broadcast blocks. So, for example, the big one on the second row is the AM broadcast block, right? That's the location that you would find if you're tuning around your AM broadcast radio. A couple of the other ones on the fourth line down are television FM stations and also FM radio stations, just to give you an idea of where things are located. The chart goes from...
In fact, let's point to just a couple of common areas on this. It's kind of like a timeline. Lynn, can you point to like the AM radio band?
Yeah, now keep in mind one thing is that it's not 100% to scale. So don't, the broadcast people have a lot of spectrum, but the one thing when you look at this is that it makes it look like they have particularly in the AM broadcast band is not that incredibly wide. But here you go. That's standard broadcasting AM.
The scales become more compressed as you go down each row, just because of how much bandwidth you have on each row there. So this goes from DC all the way up to like 300 gigahertz, right? So
right,
you have
megahertz. Down there's a lot of other interesting stuff, and to get access to that right now, you still have to pass a code test within the year. That'll probably go away. But the general class gives you initial access to the HF frequencies. The extra class gives you an extra chunk of those HF frequencies, and that's probably all you need to know to get started. But the tech license is the entry key, and it's relatively easy to get. As we were saying before we started, right now the FCC has reduced the question pool to 300 questions. You only have to take a 35 question multiple choice test, and you only have to pass 21 of those questions, and you're there. And the opportunity to actually take that test is going to be presented tomorrow, and some of the other members in the group will be able to talk more about the details of that, but we will have testing here at the conference.
And I wanted to explain to people who are not very technical that the radio spectrum is really... The radio spectrum is pretty broad. Most people are just familiar with frequencies that maybe they watch television over the air or listen to FM radio or AM radio. All of these are really chunks of the electromagnetic spectrum, and this is a...
You have a difference in scale from the first row to the last row.
So you can see the AM radio band, which is more accurately referred to as the medium wave band, is near the bottom of this chart. It's pretty low in frequency. It's around 1 megahertz. And Lynn, can you skip up to the FM broadcast band? I'm just giving these bands as examples because they're the ones lay people are most familiar with, because people listen to the radio. Go ahead.
One of the things that makes ham radio fun is that we don't need as much bandwidth as the broadcasters to do our thing. Where a broadcast signal to just say maybe has to be that wide, to use a very coarse way of showing it, we only need that much. We can get by with as little as 250 hertz and still get a signal out to other people. We have to use specialized techniques. We have to learn specialized skills, but that's what makes it good. We don't need either the bandwidth or the power. It's possible with amateur radio to talk to anywhere on the planet with less than 1 watt. Compare that to the megawatts that an FM broadcaster might use.
And also to clarify the difference between the terms broadcasting and transmitting. Broadcasting, by definition, means you're transmitting a signal and you don't have a particular